I've been working on getting the A star working with my troll so that he can navigate a little bit better. We should be live on both Twitch and YouTube. There we go. That's definitely connected through now. So where I left off on Thursday, I had been working on getting the graph built for the A star to search over. At the moment, it's still only building the graph for a single chunk. I've not done a huge amount since then. I've just put a few to-dos in the code. What I plan on working on today is two things. I'll work on the first implementation of A star, and just working within the single chunk at the moment. And then I will start working on linking chunks together so that it can navigate a little further. The issue we have with with linking chunks, because the world is effectively infinite, I can't realistically build a graph for the entire world. So instead, what I'm doing is I'm building a graph for each chunk within the world. And then as the A star algorithm tries to walk off the edge of each chunk, I'll just generate extra graph as I need to. Okay, so I have to admit I'm kind of going to have a look over this stuff just to see where I was. You can see that we've got the build chunk graph method. This generates the vertices, it generates the edges, and then it returns those. And this is in a form that we should be able to search over using A star. I should also point out another thing that I noticed with my to-dos. At the moment, edges refer to vertices, and vertices refer to edges. This is going to be a problem for serializing and deserializing these graphs, which we don't want to have to regenerate the graph every time we do a search. So I do need to update this at some point to actually just store these as indices. So these edges here will be indices into a list of edges, and these vertices here should be indices into a list of vertices. What that will do is it'll let us just write the thing out as JSON and still be able to find endpoints for edges and things like that, just with an extra lookup. If we need to, we can still store them. If we need the extra efficiency, we can still store them in memory like this, but we do need to serialize and deserialize them as indices. Okay, so where do we call into this build chunk path? We call it in here. Now you'll notice here that I was making it find the shortest path of chunks to get from the origin chunk to the destination path, the destination chunk. I'm now absolutely convinced this is the wrong way to do it. We should just be loading the origin chunk and then loading other chunks as we can. So we should just load the single chunk. Let's see, how can we do this? We get the mesh, and this is just going to be the origin chunk. So let's do that. For now, we'll just make this the list of origin chunk. What's this actually doing? This is just loading a single mesh. A lot of code just to load a single mesh, but so be it. In here, in fact, let's take this and rename this one. Oops, that's not right. Let's just rename this to chunks, which just contains the origin chunk. So you can see I'm trying to leave things in a way that everything is still working on a list of chunks, but we are just not defining what that is yet. Because my first cut is only going to work on a single chunk. Path, this is wrong. And points is wrong. Path is going to be that. to do. I have a feeling that we're not actually going to pass this back anymore. This was the list of coordinates that the troll is going to pass through, and I'm not sure that's all that useful. Given the points, we should also be able to calculate which coordinates he's passing through. Decide if we actually need this, or populate it. And then we have points. To do, put the result of the A star and string pool into here. Oh, right. I don't think I need meshes anymore, in fact. I'll just comment that out for now, because everything should be working on the graph at this point. Thank you, it's my first day. Can call me Martin, Martin, or just Island54, either one's fine. Welcome to the stream. It seems pretty quiet in here at the moment. Oh no, we've got people coming and going. So just a recap, I'm working on implementing the first version of A star just across a single chunk. Then I will work on stitching chunks together. Okay, so we have our chunks. I suspect we don't even need this. We have our graph. That's all fine. So I'm going to say in here const points equals compute points. And this is going to take a list of portals. Now, if anyone wasn't here on Thursday, let me know in the comments and I will recap what the portals are. I have no problem going over things multiple times. Find shortest path. This is going to take the graph. And then we're going to compute the points given the portals. So I will, in fact, go over the portals just for my own sanity. What have we got here? So here is an example of how hexagons might tile together. And you can imagine these being triangles. You can imagine these edges just in here, all connecting each vertex to the center. And when we do a shortest path, it's going to come through a bunch of these triangles. Just you're going to have to imagine the triangles. The portals are just the geometrical edges that the path is going to pass through. So as we move from this triangle here to this triangle here, this here is a portal we're going to pass through. So it's really just the line segment we have to cross over to get between two of our graph vertices. I have not tried smaller games in the past, so it's a bit of a case of go big or go home. I don't want to fall into the trap of building something so big that I can never finish it, but I've kind of had this idea going around for ages and wanted to work on it. I kind of have the software development side of things under control in my mind. I'm quite confident I can do all of the software development. Graphic design and stuff, I'm going to have to get help with all of that. And so I will, use Fiverr when I can and maybe even lean on the community a bit. And so the focus for me at the moment is the third thing I need to have under control, which is my game fun? If the game's not fun, then it's never going to work, no matter how good the software is. So my focus right at the moment is getting a couple of the gameplay loops tested. And the one I'm actually working towards at the moment, and I've not really mentioned this on stream or in my episodes yet, I really want to test the resource collection loop. And the loop will effectively be the the character will go into some area where they need to go to collect a certain resource. They'll have to, either on their own or teamed up with someone else, they will have to then clear out some aggressive mobs from the area and then defend the area while they collect the resources. And so that's the game loop that I'm focusing on testing at the moment. So in order to get there, I need just a little bit of a combat system. And so that's what I'm working towards at the moment with this A-star. Okay, so portals is find shortest path. So when I do find shortest path, say from this point to up here, what it's going to return is it's going to return all of the geometric edges that we're going to pass through in order to get from the origin to the destination. Now, once we have those list of geometric edges, those portals that we're going to pass through, we'll then run a second algorithm that will return a list of points that the mob will pass through to get to follow that path. So there is something called a string pull algorithm, and there are a few different incantations for it. Incarnations of it. That's the one. I'm going to go really simple for now. And if I'm given a portal, which is really just a pair of vector 3s, vector 3, an array of a pair of vector 3s, the easiest way of me doing this at the moment without implementing a proper string pull algorithm is to just return the midpoints of each of these. It's not the most efficient path for the mob, but it is the easiest for me to implement for now. So this is really quite simple. All I have to return is the portals and then map those to A, B, which are the two endpoints of the portal. And that is going to map to A plus B. Now, I'm not sure why that is not existing. I thought I had a plus. I do have a plus. Here we go. Because, yes, I need to decompose this list. It's just me not being all that familiar with TypeScript. So we do A plus B divide by 2. And that is the midpoint of the portal. So given a list of portals, this should just return the midpoints for each of the portals. So that was easy. In here, we will, implement a proper string pull algorithm, which will return an actual shortest path. Okay. So next, we need find shortest path. I thought I had a graph type. No, I don't. How do I not have a graph type? What have I done? There we go. All right, I'll not define that yet. I'll just pass that. I'll just let IntelliJ do its thing. Yes, I don't want I don't like the idea of grinding it out, and I'm kind of stealing the resource gathering to some extent from EVE Online. So in EVE Online, you are in a spaceship, you go out and you mine asteroids, but when you go to an asteroid belt, there might be pirates in there, and so or bandits of some sort. So you have to clear those out, and they will continue to attack you while you're mining the asteroids. So I'm slightly stealing from that system. There are a whole lot of things I don't like about the resource gathering system in EVE Online, and so hopefully I'll be able to work a whole bunch of those things out when I'm testing that gameplay loop. But it's really important for a massively multiplayer game to to make sure that the resource gathering is balanced. You don't want resources too easy to get, otherwise they become valueless. It's economics, and if they're too hard, or if they're too boring, then they become too scarce, which can also break the game. So yeah, I'll need to tweak a lot, I imagine, when I'm testing that gameplay loop. Okay, so shortest path. I've got to remember how to do A star. I will just say that this is the A star implementation. From memory, need a stack of, it's a queue, sorry, a queue of vertices. No, don't worry about interrupting me. It's my first day. That's kind of the point of these streams. If I wanted to put my head down and work, I'd just turn the stream off. And there's normally more people than this in. We usually get up to about 10 people, but it can take people 20 or 30 minutes to get in. And lots of people watch the stream afterwards as well. So I think people quite enjoy the tangents and the distractions. Now, for A star, it's not just a queue, it is a priority queue. Ordered by, now, there's something called a cost function, which is G plus H. So G is the cost that we've already spent to get to that point, and H is our estimate of how far we have to go on our search. So let's next do a heuristic, which is estimate cost. This is going to take an origin, which is a point in space, and a destination, which is a point in space. And this is just going to return the distance between those. Now, I'm going to be covering this in a lot of detail in the next devlog episode. But the really important thing here, people talk a lot about A star returning nonsensical results. And it's actually not that hard to get A star to return much more sensible results. The only thing you have to guarantee is that this never overestimates the cost remaining. If this estimate function never overestimates, then A star is guaranteed to return the shortest path. People will sometimes try to optimize their A star implementations by making this overestimate, and that does make A star run faster, but it at the cost of non-optimal solutions. So one way of making sure that that this will always return something no greater than the actual cost is just to return the difference between the those 2 points. Because the best we can possibly do is make a beeline straight from the origin to the destination, and that gives us that cost. So yeah, this is what's called an admissible heuristic. Admissible means it will never overestimate. So once we have that queue of vertices to visit, keep popping items. Well, let's just say next item on queue. If I can spell, Q-U-E-U-E. Next item on queue. Visit each of its neighbors. Okay. So first of all, a priority queue. I am going to need to know how to do a priority queue in Node. Node.js priority queue. Okay, this looks pretty much exactly what I want. So this lets us put an item onto a queue, lets us give it a function to compare costs. So let's use this. Is it reasonably popular? It's extremely popular. It supports TypeScript. I see no reason not to use this. I need a shell. We're in the terrain directory, so now yarn add that. Okay. So our priority queue fast priority queue. Now I need to give it a function. First, second. Let me just check the documentation. So in this case, they are defining. Oh, let's take a look at this one. In this case, they're defining a queue where the highest value is the highest priority. So I'm actually going to just take this function, well, return second dot cost greater than first dot cost. Now that obviously doesn't make sense yet because I don't have a type on these. So I need to tell it the type of this queue. Does this accept a generic? No. That's all right. So I'm going to come up with a type called, that's not a type, this is a type, called a star state. And this is going to have a cost. There we go. So it's initially empty. The very first thing I need to do is put a state into it. Now, we need more than just the graph, obviously. We need to know the origin as well. Vertex. That's just a vector 3, sorry. Vector 3. And destination. All right. Now, I think I'm actually going to stop using this term vertices here. One of the issues is that I keep on overloading this, and it's very confusing. I'll do that later, actually. It can be pretty confusing when I'm talking about vertices and edges, whether I'm talking about vertices in the graph sense or in the geometry, like the mesh sense. So I will ignore that for now. Sorry, I have a bit of a change of mind there. But we do need to find the origin and destination within the graph. Origin vertex is going to be I need to know which of these vertices the origin is within. So we currently store a coordinate. I'm also going to store a position here, which is going to be a vector 3. That will let me find which node we are closest to. Yeah. Position vector 3. Swapping around a lot between American and Australian spellings, but that seems to happen a lot when I'm coding. All right, jumping back to where I was, if I can get this. Oh, my server is running in the background. I'm just going to stop that. I must have hit a button to do that. Okay. That is going to return this dot position. So we are going to take the graph dot vertices dot sort them. And then take the first one out. Now the sort is going to return first dot. I can never remember which way around this sort function is. Compare function specifies a function that defines the sort if omitted. This is going to sort in place, which isn't good. That is not what I want. Okay, I might just have to do this the old-fashioned way, which is going to be... oops, what have I just pressed? Find vertex near point. And then we are going to pass the graph Yeah, I understand. Canadian English is quite similar to Australian, right? I think you guys still use the OR, don't you, though? The OR instead of the OUR. But yeah, I understand Canadian English has a lot in common with Australian and British English. It can be very frustrating. I try to keep American spelling in code, so anything that compiles, but then I tend to fall back to Australian English in my comments. So find vertex near point. We get given that, and we'll take the origin. So find vertex near point. Get a function. Global level graph point. Let closest vertex, which is going to be a vertex. Its distance. So you are in Canadian as well. Yeah, fair enough. Yes. Color is the worst one I find, because it comes up so often in software. Closest distance is going to be equal to infinity. There we go. Vertex goes to point minus vertex magnitude. That doesn't seem right. Vertex dot position dot magnitude. If distance is less than the closest distance. This is all just to avoid taking a copy of the vectors, the vertices, sorry, which would be potentially a very expensive operation. If distance is less than the closest distance, then what's next? We need to do closest vertex is going to be equal to vertex. Closest distance, that's not right. Closest distance is distance. And then we can return the closest vertex. This can return either a vertex or I'll make it null rather than undefined and initialize that to null. Vertex or null. Okay. So we get our origin vertex. I then push that onto the queue. Queue.add origin vertex, which it doesn't like. Fair enough. So the A star state needs not just a cost, it also needs a vertex. That, comma, cost 0. If not origin vertex, then I'm just going to throw for now. I mean, that really shouldn't happen. I guess if we had an empty graph somehow, but... Okay. While q dot, well, not q dot is empty, just double check the documentation for the priority queue. Yep, that looks right. Const state is going to be equal to q dot poll. So we pull something out of the queue. We then look at the vertex edges, and then for each of them, we need to visit it. Now, visiting it is pretty easy. I just dot 2. I need to know the cost of the edge. I suspect I'm not storing that yet. Edge. There it is. From, to, and now I am noticing that this cost is really only a cost estimate. And the reason for that is when we cross from a triangle here to a triangle here, we're going to have to assume we're going from the middle of the triangle to the middle of the triangle. But it's quite conceivable that once we do the string pull, that those costs will change quite a bit. I don't think that will affect the algorithm too much. It does mean it may not find necessarily optimal solution. I'm not sure about that. So in here, when we construct, when we set to, we can say this dot underscore cost is going to be equal to underscore, no, we can just go this dot underscore to minus, oh really? Dot position. We know that 2 is defined in this case, so I will use an exclamation mark there. Position dot minus this dot from position dot magnitude. I'm going to initialize cost otherwise to be infinity. We don't traverse edges that have that don't have 2 on them. That will obviously get cleaned up shortly once we know what the how we're going to stitch the chunks together. Okay, so for each one, we need to pull out the cost, which is going to be the state dot cost. In here, I am going to say state if not state, throw new error. That simplifies that code a bit. Get rid of all these question marks. So we've got our cost. I then need to push a new item back onto the queue. Let's go grab the edge cost. Oh, what have I done there? Oh, I don't have an accessor on that. So let's put an accessor on. As mentioned in a previous stream, I do like to be explicit about these things while I'm at least while I'm designing the software, because otherwise I find that it I find it hard to keep track of what's been exposed and what hasn't been exposed. This just gives me a slightly better design in general. Edge dot, okay, that's edge dot cost. So if the edge cost is less than infinity, then we can put a new item onto the queue, which is going to be Now, I do have something wrong in my cost function for this priority queue. I'll fix it in just a moment. But q.add, we're going to put a new item. It has a vertex, which is the edge.to. It's going to not like that because that's not defined. Force it to be defined. And we have a cost, which is cost plus edge cost. So that's the cost that we have spent in getting to that point. Yeah, Mike Burns, I'm coming to the same conclusion as well. I'm not 100% sure if that's true or not, but I know that my cost here, which cost? This cost here, I'm thinking is definitely not correct, because as you do, depending on how you move through one of these nodes, it will affect the cost. Now, my triangles are all, at least on the XZ plane, they're all equilateral. So I'm not 100% sure if it will affect the outcome of the search. So yeah, I'm not 100% sure at this point. I am going to leave it for now. I should probably put a comment that I have concerns about that. But yeah, I agree that that is dubious. The optimality. Yeah, so I will come back to that. I can't convince myself that this is either right or wrong. But I do have concerns about that. Okay, so it doesn't like this vertex for some reason. I'll sort that out in a second. We do have a cost applied here. I do need to change my priority queue. It's not enough to use the simple cost. We also need to use the heuristic. So I think I might store that on my state rather than, because I'm not sure how this priority queue behaves. I'm not sure if this is a dynamic cost. And so I might as well just store that in here. I'll just store it as heuristic. Heuristic cost. I'll call this expended cost. Let's go expended cost and remaining cost. That's a bit more obvious. And in here, we need to compare the expended cost plus the remaining cost, and first dot yeah, I'm very much hoping I don't need to do the string pull while I'm doing the A star. And all of the sources I've found do suggest that it's a separate phase of the search, except in a couple of really trivial versions of the algorithm. So I think I can do it this way. I'm just not sure if I'm specifying the cost correctly. Okay, that should be a first. All right. So what have we got? We're calculating the costs correctly now. We've got the expended cost and the remaining cost being done. When we add this one, we've got the expended cost is 0, and the remaining cost is going to be the what did I call it? I called it estimate cost. This is going to take the origin and the destination. Now, with A star, I mentioned at the beginning of the stream that this cost should never be allowed to overestimate the remaining cost, otherwise you'll get a non-optimal solution. I have a feeling that there is a situation where this can overestimate the cost, and that is where your origin is positioned such that this distance happens to be greater than the distance between the vertices. So I can slightly improve that by going and just grabbing the position off the origin vertex. I should technically do the same for the destination, but I don't necessarily have it loaded yet. I guess that's easy enough for me to do. Let's just do that. Is going to be find vertex near point, give it the graph, give it the destination. If not that or not destination that, then couldn't find endpoints. So now what I can do, will it space it out for me? Yes, thank you, IntelliJ. We can now do that. We can do the destination vertex dot position, and now it will return a cost that's guaranteed to be no greater than the actual cost according to the algorithm. All right. Next, I'm missing over here. This needs to be, what's the, are the vertices in my search the vertices of the faces of the nav mesh? No, unfortunately not. And I'm probably going to rename the nav mesh vertices to be nodes instead of vertices to get rid of that confusion. My nav mesh vertices, they represent the center of the face of the actual mesh. So I'll see if I can pull up triangle plane. No, that's not quite what I was after. Tiling of the plane. So if this is my mesh that's rendered in Unity, there is a vertex for each of these faces in my nav mesh. And then the edges in my nav mesh represent the links between these faces. You'll see the term portal used in my, let me make this a bit bigger. All right, this picture here will do. So each of these faces is a nav mesh vertex. I have an edge going between adjacent nav mesh vertices. And then I also use the term portal, and portal comes from the string pull algorithms. A portal is actually a line segment that is traversed when going between two vertices in the nav mesh. So when I do an A star, the actual result of the A star is actually going to be a list of portals, which are these line segments that we're going to be passing through to get from the origin to the destination. I do have this compute points. Given a list of portals, I have compute points so that I don't have to implement the string pull yet. I'm actually just taking the midpoint of those at this point in time. Okay, now why is this not working? This vertex... type vertex. Oh, it's missing. Okay, let's just give it. The remaining cost is going to be the estimate. Estimate the cost. Yeah, tessellate the plane with stealth bombers. Not quite the kind of plane I was talking about. All right, what have we got here? We've got the edge dot two. The edges are going to something else. What are they going to? Something is not happy here. Is it just that 2 could be undefined? Is that what it's complaining about? Ah, I see. Uh, yes, 2 returns a more complex structure. That's fair enough. Ah, what am I doing? Okay, so that needs to be vertex. Uh, expended cost. Let's go. Expended cost is going to be that. I can probably just do plus edge cost. All right. I'm all a bit over the place implementing this. So I'm going to require that it has a 2 vertex, require that the expended cost is less than infinity. I know that's going to be the case. Now I can get rid of some exclamation marks. That can be a 2 vertex. That one can be a 2 vertex. And then destination is still going to be the destination vertex. But this needs to be position, position. Okay. Does this seem about right? So we keep doing these. Now we do need an exit condition in here. We obviously don't want to continue forever. So if when we reach the destination, we need to stop searching. Now, my own background in search, the exit condition is often a lot more complicated. So my background in search is around transport systems, and you need to be a little bit careful terminating your search because you're not guaranteed to search things in order, but I think we're guaranteed to search things in order here. We go through each one. We need an exit case. I think I need to convert this to just do a for loop so that I can actually return a value. My states need to actually store the path that's been followed, or at least be able to regenerate it. But we definitely need some sort of a list in here. A list of costs is one way of doing it. But I think I might just maintain. I just need to think through this, pulling the result out of these states. I think if I store a reference to the parent state, but allow that to be null, because we do need the root state. So there we go. There is a root state. Whenever we put a new state on, we can just do parent state is going to be it's just going to be state. It's the state that we're currently processing. Then seems fair. So before we actually visit it, let's just say if the to vertex is the destination vertex, I'm going to return. This is not going to do what I actually want, but I'm about to factor out a bunch of this code. If I then return this new state, so I'm going to do const new state is going to be equal to that. Now, if we have just reached the destination, then return the new state. This is not correct. Hold on. We may well visit a node, but still have better options back on the queue. So we can only do this check when we are processing a state that we've pulled off the priority queue. Oops, what have I done? Sorry, I've got a feeling I'm clipping a bit. Just going to turn my gain down just a tiny bit. There we go. All right. So I still need to put that check in. So if we didn't get as we pull a state off the queue, if we don't get a state, then throw. In here is where we want to say, hey, if the state.vertex is the destination vertex, then return the state. There we go. This is better. This guarantees that we will check any other paths that are shorter. All right. Now, people will notice that this using A star for me at the moment is absolute overkill because my graph is complete. All my triangles in my mesh all connect to their neighbors at the moment, but that will change as I put glyphs and things back into my mesh, and I can also implement a function that allows certain mobs to not be able to pass up and down certain slopes and things like that. So once I get round to that, this will be all worth it. But without that stuff, I might as well be doing this as a Dijkstra search. All right. So here we are currently returning the state, but that's not what we want to return from this function. So what I will do is I will take all of this stuff. Is that right? Yeah. And I'll factor that out. IntelliJ will thankfully do for me. Get shortest path, path state. Const shortest state. I'll just call it state. And then I need to turn that into a list of portals is what we're expecting to return from this function. So get rid of my comment up there. Get rid of that comment. In fact, this queue should also live up in that function. I could have just renamed the function, couldn't I? Oh, right. So states is going to be an empty list. So what I'm going to do here is I'm going to build a list of the states. Fortunately, this state points to its parent, it points to its parent, it points to its parent. But I need those in reverse order. Um, so what I can do is I can say the parent state is going to be equal to state. Just initialize that so that it's not null. And then while parent state is not null, I can do states is going to be equal to parent state. Parent state is, yeah, I know there's a bug in a compile error there. That should be states.push. State.parent state. No. Oops. A star state or null is, welcome Alphil, currently implementing an A star search algorithm for the first aggressive mob in my MMO that I'm building. Still doesn't like this. Because state could be undefined. Oh, Alphi, sorry. Sorry, Alphi. I hope I'm pronouncing that correctly now. I apparently defined the queue twice. Yes, so I do. Alfie, sorry. Sorry about that. I nearly corrected myself to Alpha ED as well. I'm like, why does he have a D there? And then I worked out that it was a smiley. Well, a frowny. All right, thanks for joining us, Mike Burns. And yeah, hopefully see you next time. There will be a devlog, a devlog episode next weekend covering all of this A star stuff, assuming I get through it all. But thanks for joining us. Okay. Where is this thing at? I don't need to pass the queue anymore. It still doesn't like this because this function can return an undefined. How does it return an undefined? Oh, yes. Yeah, this is a problem. I guess I can just return null in the case that this goes bad. I don't know how to get the inspiration to do an actual project. If you want to come up with, if you want to work on a game project, I would recommend just copying something else. Like uh, before I started this, I was just messing around with. I made it like a 3D Flappy Bird, so didn't release it or anything, but it was just trying to get my hands on a bit of code. Um, I would strongly recommend doing just finding a simple game and seeing if you can reproduce it. And then maybe you can iterate on that and maybe combine two ideas, maybe, I don't know, combine Flappy Bird and Pac-Man or something. Um, and yeah, I think it's a good way of just coming up with a project with limited scope. So Flappy Bird, everyone knows how it works. Um, and so you're not going to do something like I am at the moment and end up trying to develop something that's going to take you a year or so to make. Um, So yeah, that's my recommendation. But you definitely want to keep the scope of learning projects as small as you can. All right. What have I got here? So states, we push the parent state on. We need to say that the parent state is the... All right, this is a bit silly. Let's rename that one to state. Let's rename this one to shortest state. Target state. I mean, the names don't really matter all that much, but start at the target state. While the state is not null, states.push state. And then state is going to be, oops, what have I done? No, I don't need help. I need to just not mash my keyboard. Free engines that let you use C++ for scripting. Yes, two engines come to mind. So I believe Unreal Engine has a free license, and but the other one that I'd recommend looking at, while I've not used it myself, I've heard a lot about it, is the Godot engine, Godot. Um, uh, it, I believe, allows scripting in C++. I mean, Godot's quite flexible. It lets you do C Sharp, C++, some internal scripting language that they support. So, yeah, that's what I would recommend there. My game is in Unity, so that's not what I'm doing here. This is all the back end that I'm working on here. My front end is written in C Sharp, and my back end is written in TypeScript. Very strange choice for a game, I know, the TypeScript, but it lets me get stuff going nice and quickly. What doesn't it like here? Expected 3 arguments, because we need an origin and a destination. Both vector 3s. Just options dot destination. Yes. Okay, then we can compute points. That's probably just got the wrong type. Yep, that's returning void. So back in here, oh yeah, all I'm doing is putting the states into a list. So now I can do states dot, can I just do a reverse? Yep. Just make sure that runs in place. In place, excellent. So then I should be able to just return states.map. State goes to. You know what I don't store on a state? The edge that I followed. Followed edge itself is going to be an edge or null, because a parent state cannot have followed an edge. So we'll just set followed edge to null. And then when we put an edge in, sorry, I'm a bit all over the place here. My mind sometimes gets jumbled, which means I start developing all jumbled. Followed edge. We have an edge, yes. It doesn't like the push here. That's because it's called add. All right, back to pulling the path out. Now, I'm defining path to be a list of portals, so it's just going to be state dot followed edges dot to dot portal. I am going to need some exclamation marks in here, maybe. Hang on. I know that state is not null, so I will override that one. Followed edge. When we get to the top state, we will indeed have a followed edge that's not null. So I'm going to just filter that out here. Oh, what have I just done? Pasting stuff everywhere. State goes to state dot followed edge not equal to null. And then we're going to map. Shouldn't need that. Followed edge is defined. 2 should be defined. I have a feeling that should work. Definitely going to need to test this. In fact, I might need to write some unit tests in here. I know I should write more unit tests, but it's just not as fun as developing code. Okay, I almost have my code compiling. Paths will be that. Points is going to be points. Comma expected. Simplify that like that. And I think my code's compiling. I've got a whole bunch of code here that doesn't actually get called. I'm just going to ignore that. Run the service and see if it works. I would bet good money that this does not work. I know I should be more confident, but all right, so what am I doing here? My search algorithm has a weakness where I cannot search outside of 2 chunks. Sorry, I can't search between chunks. I can only search within a chunk. So, hi Griffith, how's it going? Just finished implementing, well, a first cut of the A* implementation, just within 1 chunk. And I'm about to give it its first test, so we're about to see a crash. That's a breakpoint. Let it run through. Well, it didn't crash, but it also didn't return any points. So a distance of 2, we're expecting it to pass through, I guess it's at least 3 triangles, I think more than that. Okay, where do I start? Let's start by looking at the actual A* implementation. What I'll do is I'll breakpoint here, step over it, just to see what comes out of A*, and that just crashed. That's the thing I thought I had fixed. Let's try that again. For anyone new, these crashes I don't believe are actually my fault. It's something to do with my development environment. Causes my node process to crash. All right, so target state, we do have a state coming back out, but it has no parent. Okay. So what I'll do next is I'll step into the more detailed code and see how it is building up the states. We initialize a queue. We find the vertices, the origin and destination vertices within the graph. I'm going to add an initial state. So this has no parent state and it has no followed edge. We have the origin vertex. Let me just confirm that origin vertex and destination vertex are different. That is probably what's going wrong here. Those two vertices are the same. That's not a good sign. Now, I'm pretty sure that those two values should be in different triangles. With a z coordinate differing by 3 meters, they should definitely be in different triangles. Oh, I am going to have to finish up the stream. I just realized that time has gotten away from me. Sorry to finish up so quickly here, Griffith, after you arriving, but I have a 12 o'clock appointment that I need to make it to. So I am unlikely to make much more progress on this afternoon. So I'll be streaming again tomorrow and hopefully make more progress then. I do apologize for the very quick end. Time has gotten away from me. So thank you everyone for joining me. And tomorrow I will continue work on this. If I do get some time on this afternoon, I will probably just try and debug what it is specifically failing in here, so that we can get the list of states out. So until next time, I'll catch you all round. Thank you very much.